A previous video was on bonding in water. This video will look more in depth at properties of water. So when we think about properties of water, we will review why these properties are related to polarity and hydrogen bonding. We'll discuss the cohesive properties like cohesion, adhesion, surface tension, and capillary action in more detail. We'll look at the thermal properties and the solvent properties, not just universal solvent, but more. We'll talk about the fact that the density of ice is less than the density of water, and we'll discuss pH. So the details of properties of water are actually on the back of this big sheet. So I'm going to flip it over now. All right. So the big question here is, how do living things depend on the properties of water? So not only do you need to know what the property is, you need to know why that property exists and why it's important for life on Earth. So we can start with density. The density of ice is less than the density of liquid water, so it floats. So this is the property. Why does this happen? This happens because we talked about this before, and I'll zoom in a little bit, okay? When we look at water, right, I'm going to remind you, when we look at a water molecule, okay, you have a big oxygen atom, which is super electronegative. You have two hydrogen atoms, and they're supposed to share these two electrons. But because oxygen is so electronegative, oxygen really pulls on these electrons, and the electrons spend more time with oxygen, even though they're shared between the two. So this bond right here that I've drawn in pink is known as a polar covalent bond. And water has two polar covalent bonds. As a result of this, the oxygen has a slight negative charge, and the hydrogens have slight positive charges. Because, like I said before, sorry about that, the electrons spend more time around the oxygen, so they're slightly negatively charged. Okay, so these are polar covalent bonds holding one water molecule together. If we look at a second water molecule, we have the oxygen and again two hydrogens. We have these polar covalent bonds inside the water molecule. And again, we have the slight positive charge on hydrogen and the slight negative charge on oxygen. So what happens is a hydrogen bond forms. A hydrogen bond is an attraction between the hydrogen, in this example, between the hydrogen of this water molecule and the oxygen of this water molecule. And this holds these water molecules together. So there's our hydrogen bond. So it's interesting because polarity leads to a lot of water's properties, often because it leads to hydrogen bonding. When we think about density, in liquid water, these hydrogen bonds are breaking and reforming constantly. So let's pretend these tops are water molecules. In liquid water, the water molecules are constantly moving around each other, and so they can get really close together. In ice, the hydrogen bonds form, and because water is frozen in place, each water molecule is exactly one hydrogen bond from the other water molecule. So they're evenly spaced, and that means the water molecules in ice are spread out more, okay? So ice is less dense. I don't know if I said ice is more dense, but ice is less dense because the water molecules are spread out more. So the ice is essentially lighter than the liquid water, so ice floats, okay? So that's why it happens. The last important thing to note is, why is this important for life on Earth? That's down here. Basically, because ice floats, the ice can insulate the liquid water underneath, so the liquid water does not freeze, and organisms can exist underneath the ice in cold environments. So frogs can estivate, fish, things. Water doesn't freeze all the way because of that protective layer of ice on top, so aquatic environments can continue to exist in the cold. Also, many organisms like polar bears, etc., depend on this ice as a solid surface. So that's why the density of ice being less than the density of water is so important. Love liquid water. Okay. The next properties we'll look at, we'll kind of go from right to left here, is we'll look at these thermal properties. Thermal properties, high specific heat, high heat of vaporization. Basically, these are also due to polarity and hydrogen bonding. So first, what is it? High specific heat, water has the highest specific heat capacity of all liquids, so it takes a lot of energy before it will change temperature. Okay, this is because of the hydrogen bonds. So if we want liquid water, okay, and ice to change form, because we have to break these hydrogen bonds, we have to put in a lot more heat for water to change temperature and to change forms, okay? And so what happens is if you have an aquatic environment, temperatures are more stable because the water takes more energy to change forms. Whereas if you have like a really desert, sandy environment with no water, temperatures can fluctuate a lot during the night and the day. So basically, it takes a lot of energy for water to change temperature and to change forms. Why? Because you have to break the hydrogen bonds. Why is this important for life on Earth? The importance for life is it helps stabilize temperature on Earth. Okay, so if there's large bodies of water around, they can help you maintain a relatively stable temperature. Okay, that's why maybe in our area where there's a lot of water, the nighttime temperature might be 10 degrees different than daytime temperature. Whereas in a desert, the nighttime and daytime temperature might be like 40 degrees different. Okay, high heat of vaporization is also a property of water, a thermal property. High heat of vaporization is based on high specific heat. It takes a lot of energy for water to change from liquid to gas. Okay, so when you have water, okay, you have to put a lot of energy in for the water to change from a liquid to a gas. Again, because you have to break those hydrogen bonds. Why is this important for life on Earth? Evaporative cooling. When you sweat or when dogs pant, the water evaporates off our skin or off a dog's tongue, and it takes a lot of heat energy to do that, so that helps cool you down. Okay. Next, we'll look at solvent properties. Solvent properties, we say water is a quote-unquote universal solvent. It's not really a universal solvent because not everything dissolves in water, which we've talked about. But what we mean by that is that because water, and this universal solvent is actually because of water's polarity, not because of its hydrogen bonding. So if we have salt, I'll put salt in orange, okay, and salt is NaCl. It's held together by an ionic bond. If we put salt in water, the Na separates and becomes Na plus from the Cl, which is Cl minus, okay? And water is cool because water has a negative and a positive side, right? So for the sodium to be dissolved, the slightly negative oxygen side of the water molecule is close to the sodium to help sodium dissolve. For the chloride ion to dissolve, the slightly positive hydrogens, I'm going to draw them all in, the slightly positive hydrogens surround the chloride ion, right? So water can dissolve a lot of things because it can dissolve positively charged things because the oxygen will surround those positively charged things to dissolve them. It can dissolve negatively charged things because the negative chloride can be surrounded by the positive hydrogens. It can dissolve other polar substances that have charges. It can dissolve many different types of things. What it doesn't dissolve well is nonpolar things like oil. So the universal solvent property is due to polarity. Okay, so water's polarity leads to universal solvent. This leads to a lot of other things that are important for life on Earth. Okay, for example, transport. Water can transport things in your bloodstream easily because things dissolve in water. So you can dissolve ions, sugars, parts of proteins, amino acids in water. And because of that, sorry for this interruption, because of it, they can be transported around your bloodstream. Auditorium for the staff seating. There's lunch afterwards. So here's your bloodstream, right? There's water in your bloodstream, and because things dissolve in water, little ions and things can be dissolved in the water and transported through your bloodstream. This also allows things to be transported through the ocean, because the ocean is made up of water, lakes, etc., and things can be transported. Another important item here, okay, and I say this a lot, is chemical reactions in your body that are part of your metabolism happen in water. So it's an aqueous chemical reaction. So when we're making and breaking bonds, okay, not only can chemicals be transported in water, they are actually chemical reactions happen in water to help you survive. So for example, if you want to make a bond, like let's say these are amino acids and you want to make a protein, okay? Water can be removed through dehydration synthesis to form a covalent bond to make a protein, okay? Let's say you ate food and you want to digest something. Well, let's say this is a big sugar. Water can be added to break the bond for hydrolysis, right? To break things apart. So in biology, we always talk about chemical reactions happening in aqueous solutions or water. So it's important to make or break chemical bonds. The last properties we have over here are cohesive and adhesive properties. Cohesive properties are when water sticks to water. Adhesive properties are when water sticks to other things. So, for example, with cohesion, water can stick to each other and form surface tension. Surface tension can create droplets. Surface tension is also important because if you have like the surface of a water, like a lake or something, I'm not a very good artist, obviously, okay? Like bugs and things can walk across the surface of the lake because of surface tension, okay? Adhesive properties are when water sticks to other things. That's what forms the meniscus, right? The water molecules here are sticking to the sides of this graduated cylinder. Okay. Both cohesion and adhesion lead to capillary action. So if you have a tree and you have a tree trunk and water comes from the roots and is pulled up the tree, the water in the tree trunk is going to be pulled up the tree for a couple reasons. One, the water molecules will stick to each other, cohesion. Two, the water molecules will stick to the tubes inside the tree trunk, adhesion, and that will help the water move up the tree because as the water comes out of the leaves, it evaporates and that pulls up the other water behind it. So this is kind of the important section for life on Earth. The last property of water we'll talk about actually doesn't have anything to do with polarity. Okay, water has a neutral pH. Okay, so if you think about the pH scale, water is around 7. And in our bodies, a lot of enzymes are set to work best at a neutral pH. Okay, some parts of our body, like our stomach, is very acidic. Our small intestine is basic, right? But most of our body operates at a neutral pH, which allows our enzymes to work because they are kind of specified for a neutral pH. Now, the enzymes in our stomach work best at an acidic pH. The enzymes in our intestines work best at a slightly basic or alkaline pH, but many of the enzymes in our body work best at a pH of around 7, and that's because our body is made up of water. So, thank you so much for watching my video on properties of water.